Thank you. All right. Little housekeeping. If you could kind of silence your phones, that'd be fantastic. And again, thank you guys for coming. Really excited to talk about testing. Don't get overly excited about it. I know that. Anyway, as you can see, we're going to be talking about testing our orchestrations. And my name is Austin Papp. This is Matthew Phillips. And we're from Bloomberg and we're SREs. So before we get started, one of the main goals that I wanted to put out there, we wanted you guys to see something that works, that is working in a production environment, is how we handle our tests. And more importantly, you can start to see some code, take that back to your workplaces, apply it, use it if you can. All right. Before we jump into some of the technicals, let me do a quick profile of what's actually executing through our Salt infrastructure. Those top three items up there, we have complex batch jobs. These things run 24/7, right? We have no maintenance, no downtime. Operating system upgrades, server provisioning, and finally, of course, we always have remote executions and we always have state executions. What's really nice is we supply an environment for SRE teams to do pretty much whatever they need to do in order to satisfy their day-to-day routines. But back to what we're here for. In order to run a successful, stable, functioning infrastructure, we have to test. We have to test our orchestrations. Oh, one more. Which leads us to our problem. Well, how do we test orchestrations? And equally important is how do we test our orchestrations in a multi-node topology? Now that topology could be, say, I don't know, 3 masters, a minion, 6 masters, 10,000 minions. You know, it's really dependent on whatever you guys are running in your production infrastructure. And with that, I will pass it over to Matt, and he's going to take a look at the testing ecosystem for Salt.
Right. So yeah, when we were originally doing this work, we kind of evaluated the landscape of what people were using for testing solutions in the Salt community. We went through each of them. Each of them had a specific use case. They had their pros, they had their cons. But unfortunately, nothing was really made or geared towards testing orchestrations, which was mainly what we were working with at the time. So yeah, let's just go through each of them. The first thing we looked at was something called SaltStack. This is something that's been bundled with Salt as of 2018-3, I think. And it provides a state-like domain-specific language. So if you guys are familiar with writing SLS states, presumably you are, you should be pretty familiar with this. It should look familiar. And it's actually similar to InSpec, which is a Chef community tool. And it lets you write unit test-like assertions. And what's cool is you can write it for both your test suite, like something that's just like offline tests, but you can actually point it to your live servers as well. So it can be used kind of like as a compliance tool. But unfortunately, it isn't really something that helps us test orchestrations, so we kept looking. The second thing we looked at was runtest.py, which is SaltStack's upstream test suite. And if any of you ever contributed like a bug fix or anything like that, you probably encountered this in some way. I think right now they're in the process of converting this to a Pytest plugin architecture, but at the time it was mainly built off of a unit test directly. And it's very robust, very flexible, but that unfortunately comes at a cost. It's also fairly complex to work with, and it's not really something you can easily take and just plug into your own test suite and run tests on it. So unfortunately, it didn't really fit what we were looking for either. The third thing we were looking at was Kitchen Salt, and to understand what that is, you have to know what Test Kitchen is. And Test Kitchen is another tool that came out of the Chef community. It's basically a test harness for provisioning test instances, deploying your code, and then verifying or running your tests on them. Now, this was made by GT Manfred back in the day. Yeah, and now what Kitchen Salt is a provisioner for Test Kitchen. So what that does is it deploys Salt Minion to those provisioned machines that Test Kitchen spins up. So luckily, Test Kitchen was flexible enough to support tools that aren't specifically Chef, but unfortunately, it was still tied to a single node kind of workflow. So that didn't really fit the bill either. So the current tech didn't really solve the problem. Kitchen Salt and SaltStack can't test using complex infrastructure, doesn't let us test orchestrations. Run-test.py is kind of limited in how you can work with it with other technologies. Doesn't easily let you test your own modules, runners, states, etc. And it's fairly complex to integrate with. So
which leads us to a problem. What do we do? Where do we go? Where do we look? Like, how can we start to solve this problem? And as good engineers, we figured, all right, well, I'm sure someone's done something really clever out there. Let's go find it because I don't feel like reinventing the wheel, right? Well, okay, so we look at some options, right? I'll start over here on the right. Chef via test kitchen. Someone kind of laid something out. They had some options out there, didn't really work. And just keep test kitchen in the back of your mind because we're going to kind of come back to that. Control M. I don't know if many of you guys heard of Control M. Needless to say, enterprise solution, closed source, not a lot of literature out there about how people are testing or even if they're testing. We don't know, which leads us to Ansible. Now, before I get into this one, I want to frame this conversation around 2017 because we found Molecule at that time, and we noticed that it was using Docker for drivers and Testinfra for the infrastructure communication, testing, and validation. But key problem, had a hard dependency on Ansible. And with that hard dependency on Ansible, not really an option for us because we're using Salt. So some stuff looked interesting. Some stuff didn't fit. What do we do? Where can we draw our inspiration? And we kind of pulled some more of that, the community tooling out there. We looked at, okay, well, we write a lot of Python. So what's Python doing? Like maybe there's some things around that. And that led us to our answer. Pytest, Docker, and Testinfra. Pytest was kind of like a no-brainer. It's used in the whole, within the Py community. It actually had Docker integration off the bat. So that was a big win. And it's heavily invested in this concept called fixtures. And if you don't know what fixtures are, not a big deal. But if you've ever written unit tests, it's exactly like the setup and teardown sections of that particular technology. But the important bit is fixtures encapsulate everything. This is a very, very important concept to understand in order to glue all this stuff together to test our orchestrations. Docker was another no-brainer because SaltStack was super kind and allowed us to use images that had minions and masters already available to them. And finally, Testinfra. Testinfra was that you could say interface to the infrastructure. It allowed us directly to communicate to whatever it is that we're standing up. So in other words, it's that glue between Pytest and the infrastructure that you're trying to stand up. All right. Who's ready for awful visualizations? Yeah, because they look, yeah. So I'm not an art major, so bummer. But anyway, we're going to always look left to right. In this particular case, we're using Pytest to stand up infrastructure. We use something called Docker Compose. And if you don't know what Docker Compose is, not a big deal either. Just think of it as a schema that you define in a file, and it tells you how to stand up your Docker infrastructure. So in this case, when we're provisioning our infrastructure, we're using a Docker Compose fixture to bootstrap the Docker infrastructure or the Docker images, right? So in this case, it would be the masters and the minions. Okay. Next, Testinfra. Testinfra, like I said, is that glue. When Pytest fires up, it needs to communicate something to the infrastructure. Testinfra is where you're going to go. So that fixture exists to communicate there. Now, what's really cool is, as we'll see in some upcoming slides, is the structured data coming back to Pytest flows through Testinfra. All right. And finally, executing a command in this infrastructure. As you see on the right here, we have a master and minion. This is nothing unique. We're not winning any Nobel Prizes for this one, right? But we want to run a test version against our minion. So how do we do that leveraging Testinfra and Pytest? Pretty simple, right? Pytest calls Testinfra, puts the command on the master, and then master is legitimately running this command. There's no hocus pocus. There is no black magic. It is literally running this command. Now, that gives us an awesome equation. Pytest, Testinfra, Docker using Docker Compose, gives us, rock and roll, right? And now we are going to dive into some of the technicals. So let's pass that off to Matt. He's going to really explain this in detail.
All right. So defining the infrastructure. As Austin mentioned, Docker Compose lets you define using their schema, basically the Docker topology that you're trying to build. And I have what I have up here is actually a real example of topology that you guys should hopefully recognize. Spinning a master and a minion using the upstream salt images. Now, the one special thing is something that's built into these images that is actually pretty useful. You can set the salt master config and salt minion config environment variables. And when you do that, it drops that JSON into the minion D and master D configures. So that lets you set up a lot of scaffolding for testing things that is certainly pretty useful. Like, for example, we have auto accept on, and we're setting up a file route. The other thing is we're setting up opening the port like 4505 and 4506. And the volume is mounting our repository's salt directory into the actual file route that we're defining above. So that lets us use the image to run the code that's in our repository. And the one other thing that's happening is your Docker Compose lets you specify dependencies. So the minion depends on the master. So it'll start the master before the minion starts. And just FYI, we do have this on a repo. There'll be a link at the end of the presentation, so you guys should have access to that. Now, to actually run Docker Compose, it's pretty straightforward. Just Docker Compose up. That starts your containers. And then Docker PS lets you see what's going on. It gives you the pertinent information of the containers that are running. So that gives us the actual infrastructure topology that we're looking for. But how do we actually integrate that with Pytest? Luckily, there's actually something on PyPy, actually a very useful fixture called Pytest Docker Compose that handles pretty much all of the work relative to actually integrating with Pytest for us. If you use that fixture that comes with that plugin, it handles all the tear up, the setup, tear down, the scoping, pretty much takes care of it for you. So to see what that actually looks like, hopefully is that legible? Hopefully. Yeah, okay, cool. Yeah. So what you see here is a simple Pytest test, and it's asking for a very verbosely named function scoped container getter, and wait for salt. Wait for salt I'll explain in the next slide, but that first one is Pytest Docker Compose. And what that's doing is actually when you ask for that in your test as a dependency, it'll bring up your containers, and what it gives you when it actually passes into the test is actually the Docker Py object itself, like the actual Python API for Docker. So you can introspect any information about your Docker containers from that. So as you can see, we're actually just getting the short IDs for that, since we need to know what the minion IDs for our two containers are. And now, the other thing, wait for salt, is just a simple pattern we use. So even though Docker Compose brings up your services and lets you specify dependencies there, it doesn't actually have any built-in way to say when your services actually are ready to go. And as you guys know, salt master, salt minion, there's a bit of churn when things start. So this is just a simple while true loop, test ping. We figure out what minions we're expecting and then wait until we actually get true responses from all of them before proceeding. And this is just so your tests don't start prematurely. Now, that gives us the actual the infrastructure we need, and it has Pytest pulling that in. But how do you actually interact with these things? That's where Testinfra comes in. And as also mentioned earlier, Pytest, Testinfra is an extension for Pytest. It's actually a pretty cool tool. It's backend agnostic. It can talk SSH, WinRM for Windows machines. You can even use Docker and even SaltStack itself as like an RPC mechanism. And similar to SaltCheck, it lets you write assertions about the state of your infrastructure. So we use that in our testing, obviously, but similar to SaltCheck, you can actually also point it to real machines like your production infrastructure and use it for the compliance type of things. It's also pretty easily extensible for Salt stuff, which I'll show in a minute. So Testinfra in action. You can see it's pretty straightforward to use. Testinfra.getHost, master ID, connection, use the Docker-based connection. And then this here, master.saltrun, state orchestrate, org package, blah, blah, blah. That's actually some special sugar we added on top of Testinfra, and it's just for making it easier to interact with Salt hosts. So what's happening there behind the scenes is it's converting these args and quargs into just a CLI command as you'd run on like on the CLI, and it's actually passing the JSON outputter and returning structured data. And this is just so you don't have to write boilerplate for each test. So we're asserting here that the ret code is 0. So bringing it all together, you can combine these things and do what we're kind of trying to achieve, which is bring up some infrastructure, run a test on an orchestration that actually has multiple nodes, and then assert that it's doing the right thing. So it's pretty much what we were shooting to do. So that was it. And then Austin, is that? Do I have to click play? Oh, sorry.
All right. Oh. Is this not playing? So much for not live demoing.
Maybe that was working.
Is that working?
No.
Oh, yeah, it is. Oh, look at that.
Sorry, it's not playing on the screen.
Go technology. Okay, because there's no amount of money that anyone could pay me to live demo. I pre-recorded. Docker, as you get the top command just showing that there's no infrastructure running. The second command is what we saw earlier, where we're Docker compose up, right? So we're bringing up this infrastructure, great, right? And then it tears down. This is logging into the master, and we're showing you that a master is actually working, and we can run a test version, right? So this is the wait for stuff that Matt's been talking about. And just to show you that it's fully feature rich, right? There's nothing that we're leaving out here. Salt run, test arg, bunch of stuff comes back, right? Pop the champagne. There we go. Great. All right. Let's exit out of that. We're going to clear screen. We're going to drop the infrastructure. Oh, I'm sorry. We're actually not going to drop the infrastructure. We're going to log into the minion. So let's log into the minion. And again, just showing you that everything is in place, right? What we have here is a minion service running. By the way, it's running Pi37, in case anyone was interested. And also we're going to do a salt call test.version, just again, to show complete, this is feature rich. All right, so we'll exit out of that. And we'll drop the infrastructure. Okay, with a clean slate, now we can bring up a second window just to show you that some extra stuff. But we're going to run the Pytest, all right? And it's as simple as running Pytest. And what this is going to do is going to run something called test.package, which was the orchestration that we saw Matt hint at in the code. And this is going to install like Cowsay or something like that. But anyway, the point here is that we're showing that the infrastructure is running. And after a couple seconds of everything coming up, it will pass. I know, dead air. And finally, infrastructure tears down, all right? So the really nifty thing here is we can do this for every single test by session, by module, the list goes on. All right, now we're going to jump into some advanced topics. And with that, we pass it over to Matt.
Right. So testing on a quote unquote real machine. Although Docker and Docker Compose are actually great technologies, and they do cover quite a bit of what you would want to actually do when you're running salt states and testing it. Sometimes that just doesn't really cut the bill, unfortunately. There's a ton of different scenarios. Like, for example, if you want to test on Windows or any other platform that you don't have Docker images for, live reboots, weird stuff with service manager nuances like systemd, sysv, blah, blah, blah. There's a ton of different scenarios for that kind of thing. What you can do is combine what we've been talking about with Kitchen Salt and wrap that in a fixture as well. So what you do is use that to use the test kitchen provisioners to provision these things that you don't have access to in Docker itself. And you can actually use Kitchen Salt to pass minion config to make those minions connect back to your Pytest infrastructure. And what you can do then is actually just test it like any other minion. And we do this a fair bit as well. So it does open that up. Yep.
All right, and I apologize again for more diagrams. But I like diagrams. I like high-level views of things. If you can remember a couple slides back, we spoke about the Docker Compose fixture, What we're highlighting here is that Test Kitchen, again, is a fixture. We're slotting it into that provisioning process that's going to bootstrap whatever, right? Virtual image, say through Vagrant, say through, hey, we want to talk to OpenStack. Let's talk to OpenStack and let's spin up Windows machines. Any other service provider that you want that Test Kitchen can interface with, that's what we'll do. But again, the important bit is it is a fixture. Now, I will say there's a lot of proprietary stuff that we kind of wrote into this section of it. So this is actually working in our test suite. So we haven't upstreamed or made any of this publicly available, but anything in here, anything that we're doing this fixture is not exactly that complicated, or in this case, not unstreamable. So we're going to probably spend a little bit of time post-conference to try to unwind some of the things that we did that are a little bit tied to Bloomberg and make that a little bit more publicly available for people to pick up and possibly use in your own infrastructure. And now we're going to talk about a really cool thing called mocking web services.
Right. So if you guys are lucky, your workflows might actually not involve interacting with the outside world at all. But unfortunately, a lot of the time, the stuff that we're working with does. And most of the time, it's over an HTTP REST service. So we need to figure out some kind of pattern for just mocking those out, even if you're doing an integration test. What we came up with was just wrapping a Flask app in a Pytest fixture, and then setting the routes for that and using that as the main mock service, and then combining that with a simple pattern in our modules and runners to let us inject that mock service at runtime.
Another diagram. All right. With this diagram, I wanted to highlight two things. Pytest, and over on the right, we have the Flask fixture. They're colored the same, and the reason why they're colored the same is because that Flask web service is running on the same host that you're running your Pytest. This is not new infrastructure. This is not more Docker infrastructure, not Test Kitchen. This is running on Pytest, right? Now, if you can see right next to Pytest, we have salt run HTTP query. That's what we want to run on a host. That's what we want to run on our master, right? We use Testinfra to pass it over to the master, and then the master is going to make that request. The key here is that we are not mocking HTTP query. HTTP query is fully functional. It is doing what it does, right? It's taking the production code path. But what we're doing is we're mocking the response of the web service, so we can control a failure, a success, whatever, and write our Pytest to account for that accordingly. And the great part here is, again, all this comes back as our structured data. We use the JSON outputter, and then we can start to do our assertions in our Pytest.
Right. So what this would look like in your comp test Py, it would just be a simple fixture you drop in. You can see here, if you guys have ever worked with Flask before, it should look pretty familiar. You just create a Flask app object, define your routes, start the actual service itself, and then return that as the fixture. Now, what you'd want to do, obviously, is customize this depending on what your actual tests are and what things you're mocking. But, I mean, hopefully that should be pretty straightforward as well. Like for here, it's just a catch-all. But you guys would want to customize this for your test. Now, in the Salt side, you want to use, what we've done is a simple pattern like this. So we use like the virtual function, which runs when every module loads. Now, what we're using here is a thing called config get, which is a module that's in upstream Salt. And it's pretty handy if you guys haven't seen it. It looks at, it checks your ops dunder, your grains dunder, and your pillar dunder for the key that you're looking for. And then you can set a default as we've done. And we use that to kind of runtime set our configuration variables. So what you could also use this for is to inject your mock service address of where you're running your Pytest from. And then from that point, your modules and runners should actually be talking to your test mock server, which really achieves the actual mocking that you're looking for. Yeah.
And that was a lot. That was a lot of code thrown at you, right? We spoke about Pytest, fixtures, Docker Compose, Docker, Test Kitchen, Kitchen Salt. Yeah, there was a lot. So do not worry. We have posted the more simple things in this particular repository. So I encourage you guys to clone this down, run it. It is going to run. It's going to expose what the test package orchestration looked like. It's going to show you how to had to do some of the things we did with Docker Compose and Docker infrastructure and that sort of stuff like that. So this is actually what I ran the demo off of. Again, I just don't do a lot of demos. But before we wrap up for the day, there's two more things that we want to go over. And the first one, opportunities for improvement, because we're engineers, we're always improving. And secondly, some of the lessons learned that we got when we were doing this effort.
Right. So opportunities for improving. So if you're going to be doing something like this, the performance is not ideal, as we've come to learn, especially if you're, so it's okay if you only have a few tests, but if you're trying to scale this up to tens to hundreds of tests, the setup and tear down with Docker definitely adds up over time. Now, if you're also going to bring in something like Test Kitchen that's spinning up real machines on something like OpenStack, it definitely adds a lot of time. And if you're trying to parallelize it, it definitely takes a lot of resources to kind of run those all at once. So that's something we've been fighting with as we kind of tune this and build it out. The other thing with that, things do break often, and depending on what other external infrastructure you're bringing in, like something like OpenStack that's spinning up something like a Windows image, the more complex you get, the more fragile things unfortunately get. So it's something to keep in mind as you're kind of building this out as well.
Yeah, and with regard to breaking things, we are all unique, beautiful snowflakes in this world, and we do things slightly differently, right? And in doing things slightly differently, we introduce some problems, complexities. Maybe someone did it slightly different and it caused slightly different problems, right? But the remaining two here, as you start to worry about testing, code coverage with all your different returners and outputters and et cetera, et cetera, et cetera, you may want to do something with more Docker images, right? So like say you wanted to test a returner, right? And that returner is taking event stream, pushing it to a database. Well, maybe you have to bring up a Postgres container. And what ends up happening is you start creating like lots of directories, lots of conf test.py files, Docker Compose files. Anyway, so that can get kind of complicated and really annoying. The last one here is what I call bending Docker. We're expecting Docker to function like a complete operating system. And that's not really Docker, right? So like consider systemd. Systemd doesn't really work like a large scale, say, Red Hat system, right? At least in Docker here. So at times you feel like you're bending Docker in a way that is not native or doesn't feel native, but you ultimately do want to make sure that your test pass, and so you kind of do some janky stuff and glue some things together and whatever, right? And now let's get into some lessons learned.
Right. As Austin and I were putting this talk together, as he mentioned earlier, we kind of did a lot of this work in around 2017 or so. So when we were putting this talk together, we kind of took another look at things. And one of the interesting things is Molecule has actually matured a lot since 2017. Back then, as Austin mentioned, it was tightly coupled with Ansible. It wasn't really something you could use just on its own. But when we looked at it, it looks like the provisioners, verifiers, linters are all now configurable and pluggable. We didn't spend a lot of time looking at it, but it might actually be something that you guys could use if you were looking to do something like this today. It'd be definitely worth taking a look before rolling your own solution. So yeah, that's definitely one thing that was interesting. Other thing, testing well is hard. It's one thing to write tests, but it's also definitely a skill to write effective tests that are actually exercising the things that you want to be exercising. So that's something we continue to grapple with as we continue to build out this stuff. So,
and Mo actually hinted at this in the general session here. We're engineers and we're looking for the greatest flexibility, right? But when you roll your own solution, all this comes at a cost, right? That could be time, money, resources, whatever, right? So you kind of have to figure out, like with something like Molecule, do I have the team to roll my own solution, or can I use something like Molecule to just get this off the ground? Because zero testing, or some testing is better than no testing, at least in my opinion. Which leads me to my last one. I had to get this in because this always made me laugh. Had this infrastructure up, was running, everything's working, going through CI/CD. Tests are great. We're high-fiving each other, and then one day, like in the middle of the day, just broke. It was like boom, right? And we're like, what the heck just happened? So we're sitting there, we're looking like no new commits. We have no idea what's going on. We found out that PyYAML decided to release a new version. And as a result, we came crumbling down. So pin your dependencies. And that I want to thank everybody for coming. We are Bloomberg. We're always hiring good SREs. Come talk to us. Again, that's the link for the demo. And if anyone has questions, we're happy to fill them.
Quick question. On your Docker Compose, on your minion, I didn't notice any exposed ports. So I'm wondering if that was a typo, or if you can talk a little bit more of the network, how the containers communicate with each other. And also, if have you experimented with different Docker networks to simulate network environments?
If I remember correctly, by default, all containers within the same project, when they start up, should actually be like there's nothing blocked between them. So that's only actually for external, like if you want to externally talk to your Docker containers, like say from your host, interact with it. Okay. Yeah, so it's not actually necessary. I haven't really played with external, like handling different networks outside of just the defaults that come with each project that you start.
Okay, thank you.
Anybody else? Sure. Yeah, sorry, might have to repeat that just for the video.
Are you running on some sort of interval? Is it tied to commits? Is it, is it CI/CD? What is it there?
For all this stuff, we actually have it run for every PR. So it's just part of our test suite. So, yeah.
Cool.
All right. Nobody else? Okay, thanks, guys.